1.7, combination of functions, composite functions. Now, if you look on my channel, I already have one that deals with finding f plus g of x, f minus g of x, f times g of x, f divided by g of x, and of course any combination of those, as well as composition functions, f of g and g of f, or some notation it looks like this, but same premise. So to get more details on those, watch this video first. It's on my channel, function operations. But something else, maybe a couple other things, or maybe some messier versions of those that's not on that video. A lot of times they will give you a function and want you to know just by looking at it what's its domain. Well, if it's a line like y equals 3x minus 4, you know the domain is going to be all reals because it's just a line. There's no gaps. There's nothing weird you have to worry about. Even if it's a nice parabola, y equals x squared, or even if they put positives or negatives out there, even added other terms to it. Your lead coefficient's positive, but your lead degree is 2. You know, that's just a parabola. It's probably shifted somewhere, but it's just a parabola, so your domain is still all reals. Your basic x cubed, and then same thing, if they added the subsequent terms, it's going to look something like this. It's still going to be all reals. Where you have to watch for is square roots, and if there's something in the denominator. That's where they really try to get you on these. So like if I had square root of x minus 2. Well, we know if we graphed it from last section, that's just over 2 and a graph. Well, on this one, notice where does the graph start on the x-axis? It starts at 2, which is also what makes this 0. So that's why with the square roots, you really don't have to graph them. You can just look to see what makes it 0, and it's going to start there and go to the right. So that's going to make it, its domain will be 2. Now remember, this is domain. It's not increasing, decreasing, so you would need to put that bracket at 2. So 2 to infinity is its domain. Let's say if I did square root of, we'll do a weird one, 3x plus 5. And you're like, I sure don't want to graph that. Well, you don't have to. What makes this 0 is negative 5 over 3. And then it's still going to have the same basic shape. There you go. Negative 5 over 3 to infinity. Now, you know, they do like, or let's do one more of that before we do weird stuff. Let's say it's negative x. Negative x plus 5. What makes this 0? And you know it's 5. Well, here's the only thing. Notice how on this one, the x is negative. So remember, instead of going right, it's going left. So your graph would actually be something like that. So it's negative infinity to 5. So if the x is negative inside, that's going to make it going to the left, so it's going to be negative infinity to 5. Now, sometimes just, you know them, they'll put something like, let's say, 8 over square root of x minus 3. The 8 on top, it really doesn't matter. It's a weird graph, yes, but domain only has to do with x. So if you look at this, x3 is the smallest it can be, but since it's under That means it can't equal 3, so that's why it's parentheses 3 to infinity. So if it's in the denominator, you just have to be careful. It can't equal that number. It's got to be parentheses, not bracket. So that's one thing they try to get you at. They also make it look sometimes a little weird. Like if I said negative 10 over x squared plus 5x plus 6. Notice how in this one I know you're like, whoa, what happened there? Well, you need to find what makes this 0. They usually don't give you weird ones, so you can factor pretty quickly. 2 pluses, multiply to get 6, add to give you 5. So x can't equal negative 2 and negative 3. So think about it on your graph. It can be everything but that. So you're going to have negative infinity to negative 3, union negative 3 to negative 2, union negative 2 to infinity. So you might have on occasion where you have to factor it. It's usually not too weird, but there you go. They can even already have it sometimes, like 6 over x plus 5 and 3 over x minus 1. The two things x can't equal, negative 5 and 1. So negative infinity to negative 5, negative 5 to 1, 1 to infinity. So that is what you have to watch for those. And now just be careful if they, sometimes you have to do a little bit of cleanup work. If they, on the compositions, when you're doing the f of g's and then finding domain, sometimes you have to find common denominators, that sort of thing. I guess I could do one with you real quick. We'll just do 68 in the book. So y, or f of x, equals 5 over x plus 4. And g of x is 1 over x. So if you wanted to find f of g, all this into there. So 5 over, this is going to be so much fun, plus 4. So remember, before you can do outers over inners, you've got to get a common denominator of the bottom. So if you get a common denominator of x, that's over and understood 1, so you need an x, so multiply the top and the bottom by x, so 4x over x. Clean it up just a little. If you want, you can go ahead and put that over and understood 1. 1 plus 4x over x. Outers over inners. 5x over 1 plus 4x. And by looking at this, if you wanted to find the domain, what's the one thing that x could not equal? In other words, what would make this 0? Negative 1/4. So you'd have negative infinity to negative 1/4, union negative 1/4 to infinity. So you might have to do a little bit of simplifying common denominator for maybe a couple of them. They typically don't do too bad with those. Hope this was of help to you. As normal, if you ever have any questions, let me know, and see you next time.